Bismillahirrahmanirrahim. Dear students, welcome to the course of Big Data Concepts. Today we will discuss lecture number 12, and the main topic of the lecture is another query language which is known as SparQL. This is your teacher Tariq Aziz, lecturer at Institute of IT, Kohat University, HANGU-CAMPUS. So let's move on to the agenda. Dear students, before going into the detail, let me explain at this stage that we are discussing different query languages to query big data. First of all, we looked at the definition of big data, and then we said that if we want to model big data, then we have a couple of data models available, and we already discussed all these data models. Now, question is, if we want to query these data models and we want to extract information, then which sort of query languages are available? So we are discussing all these query languages, and we already discussed one of the query language which is known as Hive query language. But we will discuss another query language which is known as the SparQL. So first of all, we will get to know that what is SparQL, and then we will look at some data formats, and then we will look at some of the assumptions, and then we will look at the structure of the SparQL query, and then we will discuss the architecture and endpoints of the SparQL, and finally we will look at one of the data set which is known as a friend of a friend, or shortly it is known as FOAF. And then we will look at some of the queries of SparQL, that how we can extract information by using these queries. So our lecture will consist of multiple videos. So in today's video lecture, we will start our discussion with the first topic, which is the definition of the SparQL. Now, dear students, SparQL, as we said, that it is a query language, and we can also say that it is a protocol. And normally, this query language is used for linked open data, or to query the RDFS databases. Now, this query language, it is designed for R to query a great variety of data, and this query language efficiently extract information. It extract information in hidden and in non-uniform data, and it extract information which are stored in various formats and sources. So basically, this language is used for extracting information from different sources, and we will look at the queries at the end of this lecture. Now, dear students, we used a term, the RDF. What is this? Basically, it's a database, but there is another name which is used for RDF, and this name is called triple store. So you can say RDF, or you can say triple store. Okay. Now, what is this? It's a type of graph database, and it store triples. Now, what do you mean by triples? Triples are data points, and they are represented in this format. Now, here, first of all, we will have the subject, and then we will have the predicate, and then we will have the object. So this is a relationship which is known as subject predicate object relationship. This is basically known as triples. Okay. Now, dear students, data can be pulled, or it can be extracted from RDFS databases with a variety of query languages. It means that if you want to query RDF databases, then there are some other query languages, but the most common query language used is SparQL. Now, dear students, how SparQL works? It actually sees your data as a directed label graph. Now, dear students, we know that there are two types of graph. One is called the directed graph and other one is called the undirected graph. So if this is our graph, then in this graph, this is the node A and this is the node B. Now, in this graph, direction is not clear, that either we are moving from A to B or B to A. So this is called undirected graph. But if we are talking about the directed graph, then there will be a clear direction between nodes. So in this case, now we are moving from node A towards B. So this is the directed graphs. But if you put some label, then it will be called a directed labeled graph. So this query language sees your data as a directed labeled graph, and this data is internally expressed as triples. And what's the format of this triple? As we discussed previously, that first of all you will have subject, and then the predicate, and finally the object. Okay, so data will be internally represented in this format, which is known as triple: subject, predicate, object. Now, dear students, correspondingly, the SparkQL query, it will consist of set of triple patterns, in which each element, and these element are subject, predicate, object, can be a variable which is known as wildcard. Now, dear students, what about the solutions? How we can find the solutions to the variables? They can be found by matching the patterns in the query to triples in the data set. So if you have the query, let's say I am representing query with Q, then there will be some patterns inside this query. Okay, and where your triples will reside, it will reside in the data set. So let's say that this D is representing your data set. So triples are here, okay, but the patterns are here in the query. So these patterns in the query, they will match with the triples in the data set, and based on this matching, then solutions to the variables will be found. So this is the concept. Now, dear students, as a query language, SparkQL is data oriented, which means that you only query the information held in the models. So previously we said that we have the RDF database, we have RDF data model, and we want to query this data model to extract information. So it says here that SparkQL is data oriented because we query this data model and we extract information from this data model. But if you talk about the inferencing, so this query language, it doesn't do inferencing. Okay, it doesn't infer anything. So here in the second point, it says that SparkQL does not do anything. What it does is take the description of what the application wants in the form of a query, and then it will return the results in the form of information from a set of bindings or an RDF graph. So it's very simple. You have to query the data model. An application, suppose an application wants something, so it has to query this data model by using the SparkQL query language, and then as a result, this query will return information back to this application. So this is the basic concept. Okay, now, dear students, the next thing is what will be the data formats. So first, we need to be clear about what data is being queried. It's very important that if you want to query the data model, what will be the format of the data? So it's important to know. Now, SparkQL, as we said, that it queries RDF graphs. Okay, so now it's important to know that what will be the data format in this graph. Okay, so if we look at the example, As an example, search this file on the internet and you will know about the format of the data. This file, what it contains? It contains RDF for a number of vCard descriptions of people. Now, what is vCard? I am giving you this as a home assignment. So just search this vCards. You will description or the detailed information of vCards can be found in RFC 24226, but the RDF translation is described here in W3C note, and this is the note. Okay, so if you want to search about the RDF translation, then just write this information on the Google and you will find a document. Then I would suggest that you should read this document thoroughly. But with respect to our example database, it just contains some name information. Dear students, again, let me remind you that, as I said, we will not go into the detail of all these query languages at this stage. The main point is to let you people know that there are different query languages to query big data models. We already discussed one of the query language which is known as Hive query language, and now we are discussing another query language which is known as SparkQL. But we will not dig deep. We will not go into the detail. I will just give you know-how of this language. But if you people are interested, then I would suggest that you should search the internet for detailed description. Now, dear students, this is the model, or we can say this is the graphical representation of data. So look at the nodes. As I said, that RDF is one of the type of the graph database. And with respect to graph database, we discussed in detail that graph database contains the nodes. So these are the nodes, and the arrows are called the arcs. So we already discussed that the relationships are represented by the information here. Okay, so we already discussed all these concepts, and I would recommend that you should revise your concept from previous lectures. So this is the example of graph database. So here, this database basically contains the names of people. So Matthew Johns, this is the full name. FN represent the full name of Matthew John, and this is the source where we will find this name. We can find this name from this source. Okay, and then there is another edge towards the name again. So here we have a family name. A family name is Johns, and we have the given name which is Matthew. So the same is for another name is Sarah Jones. Okay, and the source is this name is taken from this source, or this source contains this name. So full name is Sarah Jones, and then we have another edge towards the name because now we want to know the family name. So in this case, John is the family name, and we want to know the given name. So Sarah is the given name. So basically, this graphical representation belongs to the names of people. So if you look at this graph database, then it represents the names of people. Okay. Now, dear students, how we will represent this graph database in triples? With respect to triples, we said that you have, first of all, you will have the subject, and then you will have the predicate, and then you will have the object. Don't confuse yourself. There is a diagram on the next slide, and I will explain these three terminologies there. But if you want to represent triples, then this is the picture. So here we have the prefix vcard, and then we have the prefix RDF. What is prefix? We will discuss on the next slide. Dear students, this is the source. Okay, this is the first source, and this is the URL. This is the second source. Again, this is the URL. So the first source is this one, okay, the URL. And here we have to represent the full name, okay. So Matt Jones is the full name, and then we have to represent the name. So in this case, this name consists of family name. So we card family name is Jones, and then the given name is Matthew, brace open and brace close, okay. So this is the representation of triples. And again, the second representation again for the next name Becky Smith, the same syntax for the Becky Smith. Full name is Becky Smith, and then we have a name because we want to know about the family name. So family name is Smith, and we want to know about the given name Rebecca, and then brace close. So dear students, uh, my point is that you people should know that this is the representation of triples in RDF database. So this is the RDF data model. This is our RDF data model, and we represent information here in the form of triples. Okay. Now, dear students, here the pattern, the triples. How can we represent these triples, or what do you mean by the triples? So this is the pattern, or we can say, what do you mean by the pattern? The pattern is basically our triple. So first of all, we will have the subject, and in this case, subject is John, and then we will have our predicate. So in this case, the predicate is has a son, and finally we will have our object, which is represented by variable x. So this is our object. So this is the representation of triple, and we called this representation a pattern. Okay. So now this pattern will have as a solution each triple in the RDF graph. Okay. Now that matches the subject and the predicate and has any object. So it will the query will have this pattern, and then the RDF graph, it will also contain a pattern like this or a triple like this. Then the query will match these information with the triple in the RDF graph, and correspondingly will return the results. So for example, this is an example. Let me explain the concept with the help of this example. We have a subject John, and it has two sons. One is Bob and the other one is Michael. So with respect to this pattern, what will be the representation? This is the representation of triple. John, this is the subject, has son, this is our predicate, and object is Bob. In this case, x belongs to Bob. Our x is substituted with Bob. Okay. And another pattern is John, again our subject, has son is our predicate. Now in this case, the object is Michael, his another son. Now in this case, x will be substituted with Michael. Okay. So this will be the result of the SparQL query. Okay. Now, dear students, this is I hope that you people are now understand that this RDF graph, it will contain triples like this. So if we move back, then we said that what is this picture? This picture is basically the representation in triples, a representation of triples. So triple will be represented like this, but the and what is this? This is our RDF graph, and we represent triples in this graph like this. But the query, it will also correspondingly contain the patterns like triples. Okay. And then the matching will perform, and query will return the corresponding results. Okay. Now dear students, let me explain the concept with the help of the picture. This is John, our subject. What is the predicate? Has son is the predicate, and what is the object? X is the object now. So with the first result will be returned with the x is equal to Bob. John has son Bob, and the second return will be returned with the result Michael. John has son Michael. Okay. So this is the basic concept of triples and patterns. Now, dear students, here it says that this is the more explicit representation as triples. Okay, you can also represent triples in RDF graph like this. So prefix vcard, this is the source, and then prefix RDF, this is another source. This is the first source, vcard full name is Matt Jones, and then name is now associated with this notation. So this notation is first associated with family name Jones, and again with the given name Matthew. So you can also represent triples like this in the RDF graph. Okay. Now, dear students, one thing is important to realize that these are the same RDF graph. Which one? They are actually this is talking about this graph, and this graph. Okay, so first we have this RDF graph, and the second RDF graph is this one. It says that both of these RDF graphs are the same, and that the triples in the graph are in no particular order. If you look at the order of these triples, then here, with respect to the graph database, this is the graph database. So here we have first Matthew Jones, and then Sarah Jones, and then Becky Smith, and then John Smith. But if you look at the RDF graph, then we have Jones Matthew, and then we have Smith Rebecca. So the order of the name is changed. Same is the case with this RDF graph. The order of the names are changed. It doesn't matter. Okay, it doesn't matter. It's only for human, so they can read these information easily. So but the machine, they doesn't care about these ordering. So it's only for human to read the information easily. Now, dear students, uh, this is all about today's video lecture. From next video lecture, we will continue with the assumptions. Thank you.